to another video of M2 to Sylvia. In this video, the category is math and the topic is solving quadratic equations. In case you don't know yet, a quadratic equation is an equation of the form ax squared plus bx plus c equals 0. Sometimes 0 is not a 0, but another constant. In that case, you can just subtract the constant from here to get it into this form. And there are three major ways of solving a quadratic equation. Number one is factoring as a product of two monomials or binomials. A monomial is basically just one term, like an x term or a y term, or just a constant. And a binomial is of the form ax plus b. Number two is completing the square. Don't worry, I'll explain this in this video. And number three is using quadratic formula. If you don't know what that is yet, don't worry, I'll explain that too, and I'll even explain how to get it. So this is factoring. Well, not yet. I'll explain what that is. This doesn't look like your regular old linear equation, does it? Linear equations make sense. A lot of sense. I mean, a lot of people know how to solve linear equations, but quadratics, maybe not so much. This doesn't look that easy, right? I mean, even if we could isolate the x squared term, there's going to be the x on the other side. How annoying! It's almost impossible to isolate the terms now. Well, we can factor it. See this 2? Well, first we know that it's a product of two binomials because there's a constant term. So this 2, the two factors would go here and here. Something x times something x to make the x squared term. So 2 is equal to 1 times 2. There's no other way to put it. Just 1 times 2. You're going to use integers. Or 2 is equal to negative 1 times negative 2. But this isn't negative. How can we use negative terms when there's no negative sum? So this is not what we want. This is. And I don't think we want to use that for negatives either if we don't use this negatives. Because then, once again, not a negative term. And since it's just 1 and 2, let's just put 2 here and 1 here. And the 1x is just x. Easy peasy lemon squeezy. Since it's both positive, plus and plus. And here comes a teensy-weensy bit of guesswork. Yes, math is usually not about guesswork. When there's so few options, it's okay to guess. So, if this is a 2, why not put this a 1? So this must be the 2. And now let's see if the 2 in very inside terms times the 2 very outside terms is equal to 5x. Because that's the sum of this times this. And so 1 times x is just, well, x. And 2x times 2 is 4x. 4x plus x is 5x. Success! So this is our factorization. Whoops. Don't forget that it equals 0. But then, how do we know what this has to do with the solutions? Well, two numbers multiplied together only produce 0 if one or both of them is 0. And so either this one is 0 or this one is 0. Yes, there can be two solutions to a quadratic equation. Amazing, isn't it? Well, when 2x plus 1 equals 0, hey, this is just a linear equation. X plus 1 equals 0. 2x equals negative 1. And so x equals negative 1/2. What about the other solution? Wow, another linear equation. Yay! Who knew there could be linear equations in quadratic equations? So, x plus 2 equals 0. X equals negative 2. Our two solutions to this. And that's how you factor a quadratic. Sometimes there are equations that don't look very factorable with a first method. Because see, -5 is 1 and -5, or -1 and 5, and neither of those sum to 2. So how are we going to solve this? Well, there's a handy dandy formula for a plus b, this entire a plus b squared. That's a squared plus 2ab plus b squared. If you're wondering why, look at this little diagram here. A times a is a squared. This is the area. B times a is ab area. A times b is also ab, and b times b is b squared. And since this is a square with side length ab, it's a plus b entire thing squared. So how are we going to use this here? Because a could be x, because a squared is equal to x squared. And then since a is x, 2xb is equal to 2x, and b is 1. But this is not 1. It's -5. What do? We add 1 and we subtract 1. What does that do? Nothing, because plus 1 minus 1 is equal to 0. But then we can get it to x squared minus 2, well, plus 2x, not minus, plus 1 minus 1 minus 5 equals 0. See how handy dandy that is? Now just x plus 1's quantity squared equals 6, because this is 6. Well, this will total to -6. We add 6 to both sides. And then, so we can take the square root of both sides. X plus 1 equals plus or minus square is 6. Because the product of two negative numbers is a positive number. And so, x equals -1 plus or minus square root of 6. But what happens when this is positive and so you subtract it? You can't take the square root of a negative number, can you? Well, actually, you can. It's called complex numbers. And square root of -1 is equal to I. So when it's negative, it's just I times something. Very useful, isn't it? Terms with only I and no other real terms, which are basically things without any mention of I at all. Well, without any real terms, just the I term, it's called imaginary. So if this was plus 5 here, -1 plus 5, this was 4. Minus 4 is -4 here. And so it would be, since 4 is square root of 2, and I is square root of -1, square root of -1, then it's just 2i here instead of plus or minus square root of 6. It's plus or minus 2i. Very handy dandy, isn't it? But then how do you know what the b squared to add is? Well, we have this a squared here. And that would just be the ax term, where the a is a different a from that a. So you just take the square root of ax, or x square root of a. And then you divide this term, which is generally given by 2x square root of a. So this 2ab term divided by this term, because this is this a, so 2a is 2xa. This would be 2ab. And to find b, we just divide 2ab by 2a. And that's how you find what term to add or subtract if this is negative. And that's how you complete the square. Now that we've figured out how to factor quadratics and complete the square on those that don't seem easily factorable, maybe we should find a universal method, you know? Completing the square is universal, but it's not so easy as factoring when you can do it. So, this is a regular old generic quadratic equation. And, well, it's easier to deal with ones that don't have an a term than ones that do. So let's divide it all by a. So x squared plus bx over a plus c over a equals 0. Yippity yippee doo! Now, the a in a squared plus 2ab plus b squared is just x. Everybody loves it when it's just x, doesn't everyone? So bx over a over 2x. Well, that's a little crazy. And then, well, we can scribble out that x, and then, well, so b over a equals this fraction down here is basically just multiplying by 1/2 equals b over 2a. So then we can do x squared plus bx over a plus b squared over 4a squared minus b squared over 4a squared plus c over a equals 0. And then we have x plus b over a, no, not a, b over 2a, don't forget that, 2a squared equals b squared minus c over, well, we can multiply this by 4a. But then it's not c, it's 4ac over 4a squared. Now, let's take the square root of that. So x plus b over 2a equals plus or minus square root of b squared minus 4ac over the square root of this is just 2a. How convenient. This is also 2a. So then we can subtract b plus 2a from both sides to get x equals negative b plus or minus square root of b squared minus 4ac over 2a. Wow, that doesn't seem like the friendliest formula, does it? Quadratic formula doesn't really seem like the friendliest formula. So many variables and square roots and plus or minus. But for me, it's just really fun to recite out loud. Negative b plus or minus square root of b squared minus 4c over 2a. And, well, if you can't memorize it, but you can easily remember completing the square, then maybe in your spare time, you can use completing the square to figure out the quadratic formula on your own. And it makes a lot more sense when someone explains how you get it instead of just throwing it at you. Hey, use that, take it for granted. Don't ask. But then when you explain how you get it, it just makes a little more sense sometimes, doesn't it? And that's a quadratic formula. Thank you, everybody, and I hope everyone now knows how to solve a quadratic equation, or at least everyone who watches this video. Thank you, and goodbye.